So in section 8.4, which is on page 595, we're going to cover rationalizing the denominator. So what is rationalizing the denominator is when you have radicals in a denominator, like for example 1 over the square root of 3, or maybe 1 over 3 plus square root of 3, or maybe 1 over square root of 2 plus square root of 3. So we have radicals in the denominator. We might have radicals in the numerator too, but we don't care. So we only worry about not about having radicals in the denominator. So we want to eliminate the radicals in the denominator. So rationalizing means removing radicals. So we're going to rationalize the denominators here, but in other courses of math, you might need to rationalize the numerator, so that is also possible. But rationalizing then, in this case, is just removing, trying to eliminate radicals, in this case in the denominator. In other cases, it would be the numerator. But for us, for this class, we only are going to rationalize denominators. So we're going to start with examples. It's going to be just very simple, the process. We have a process when you have a single radical or one term, in other words, one term in the denominator, and when we have two terms in the denominator. So the process is slightly different. So we're going to start with the first case when you have just one term in the denominator. So we're going to solve example 1, on page 595, and it's just about rationalize the denominator. So we have the first case is 15 over square root of 6. So we have here a radical in the denominator. We don't want that radical. So one way is just multiply the denominator by the same radical that you want to eliminate. That's one process. That's the simplest one. So you just multiply by the same radical in the denominator that you want to eliminate. Other way is I'm going to try or multiply by a radical that gets you a perfect square in the radical of the denominator. And when I say multiply, you're going to multiply both the numerator and the denominator by the same quantity. Remember, that's what we do to prevent mistakes. So in this case, we have 15 over square root of 6. I want to eliminate this radical, so then I'm going to multiply the numerator and the denominator by that radical, the one I want to eliminate. So if I do this, I'm just going to get 15 times the square root of 6, that's the numerator, and I'm going to multiply square root of 6 by square root of 6, so it's going to be just 6 squared, because you are multiplying 6 times 6 under the same radical. So now you can cancel the radical sign and the exponent. So you're going to end up with 15 times 6 square root of 6 over 6, because we removed the radical sign and the exponent. Finally, we just need to simplify the fraction that results from that. So in this case, you can see that you can divide both the numerator and the denominator by a quantity, but also you need to simplify the the radical, because remember we can simplify radicals by multiplying those radicals by factoring the radical. So in this case, for example, the square root of 6 can be written as the product of 4 and 2. 4 is a perfect square, so let's do that first. So 15, then we have 4 times 2 is going to be 6, and then over 6. So now you know that the square root of 4 is 2 squared, so it's 15, and we write 4 as a perfect square. The radical 2 remains as that, and 6. So we have finally 15 times 2, square root of 2, and over 6. So this is because we cancel this radical and this exponent. So now the final step is simplifying the fraction here. So we have 15 times 2 over 6. So you can just divide both the numerator and the denominator by 6. So you're gonna get the following. So you have 30 divided by 6 and multiplying the square root of 2. So 30 divided by 6 is just 5 times square root of 2. So that should be the answer. Let's check, because maybe I made a mistake. So let's see. So we got I know where my mistake is. So this part is not correct. Why? Because 4 times 2 is not 6. So this part is not correct. I only needed to simplify the fraction. So I have 15. We're going to divide 15 by 3. And we're going to leave square root of 6. And we're going to divide 6 by 3. So we're going to get 15 divided by 3. We're going to get 5. 6 divided by 3. You're going to get 2. And we get the square root of 6. Yeah, we need to be very careful, because when I tried to break this radical, I made a huge mistake. So I assumed that 6 was this result of multiplying 4 and 2, which is not correct. So be careful. So that's the first example. Now we're going to work the second part of the first example. So the second part is going to be part B. Part B. Now we're going to rationalize the square root of 3 over 5. So when you have this radical involving a fraction, the best way to proceed is we need to break this radical into parts, one for the numerator and the other for the denominator. In that way, you know what radical is the one that you want to remove. I want to remove the square root of 5 from this denominator. So I'm going to multiply by, in this case, the square root of 5 over the square root of 5. Remember, we multiply both the numerator and the denominator by the same quantity. And this, in this case, the quantity that we're going to use is the radical that I want to eliminate. So when we do this, we're going to get 3 times 5 is going to be 15. And in the denominator, we're going to get 5 times 5 is 5 squared. So you can cancel the radical and the exponent. So we remove this, so we get square root of 15 over 5, and that's it. We cannot do more than that. So let's work another example. This is going to be example 2 on page 596. So we're going to rationalize the denominator again. Rationalize the denominator. So we're going to start with 12 over the square root of 8. So again, we can just multiply both the numerator and the denominator by the square root of 8. But another way is the second option that I mentioned before, is multiply by another radical that makes the result a perfect square. And you know that if you multiply a by 2, you're going to get 16, and 16 is a perfect square. So I'm going to multiply both the numerator and the denominator by the square root of 2. Why? Because 8 times 2 is going to become 16, and 16 is a perfect square. So when you choose this method, what you are doing is just essentially saving some steps for later. So because otherwise you're going to get quantities that are going to require you to simplify the fraction. So let's do that. So we're going to have 12 times the square root of 2, and here we're going to have 8 times 2 is going to be 16. So this is a perfect square, so we're going to rewrite that as a perfect square, so by using power or exponent 2, so it's going to be 4 squared. So now we can see that we can eliminate exponent, we can eliminate the radical sign. So we get at the end 12 square root of 2 over 4. So 12 over 4 is going to be just 3 times the square root of 2. So the other way is multiplying both the numerator and the denominator by the square root of 8. So then you're going to have an extra couple of more steps to get the same answer at the end. So it doesn't matter the way that you do it. If you do it on the long way, the long route, as long as you get the answer, for me it's fine. So the other problem is going to be the square root of 7x over 75. So we said before we need to break this into radicals, one for the numerator and the other for the denominator. And another way to solve these problems is, first you can simplify the radical in the denominator. In that way we're going to get radicals that are not huge, big numbers. So we have the square root of 7x in the numerator, and 75 can be simplified as writing or breaking 75 as the product of 25, which is a perfect square, and 3. So 3 times 25 is going to be 75. So by doing this, we're going to obtain a radical that's going to be smaller than the original radical. So 25 is just 5 square, and we're taking the square root of that, and we have the square root of 3 here. So we're going to get the square root of 7x over 5 times, because we're going to remove the exponent and we're going to remove the radical. So we end up only with 5 outside of the radical sign and square root of 3. So now the radical that I want to eliminate is square root of 3. So I'm going to multiply by square root of 3 the numerator and the denominator. So this multiplication here is rationalizing. That's what we call rationalizing the denominator. So now we're going to have the numerator is going to be 3 times 7 is going to be 21x. The denominator is 5 times. The square root of 3 times 3 is going to be 3 squared. Then we can cancel the radical and the exponent. So we're gonna get 21x, the square root of that, over 5 times 3, because 3 is what is going to be left after removing the exponent and the radical sign. So finally we're going to get the square root of 21x over 15, and I think that's the end of it. story. So that's the first part. So you're gonna work now exercises where you're gonna use simplify, or you're gonna rationalize the denominator. The denominator is just a single term. So there are three options. You're gonna multiply by the same radical. You're gonna multiply by a different radical with the condition that you're gonna get a perfect square in the resulting radical, or you might simplify first the radical in the denominator to get a better radical to work with. So you're gonna work exercises from the exercise set. So 8.4 exercise set on page 600. So we have a lot of exercises that you're gonna work now. So you're gonna start with problem 8. So 8, you're gonna rationalize 40 over the square root of 5. Then we have problem 16. You're gonna rationalize 6, the denominator of 6 over x, the square root of 6 over x. Then we have 24, the square root of 2x over the square root of 17. Then we have problem 28, 15 over the square root of 50. Then we have 36 is the square root of 1 over 54. Then we have finally problem 50, which is the square root of 45 over y cubed. So you have 6 problems to work on. You're gonna send me your answers by using either the chat box or later by submitting your work through Canvas. So let's try to solve problem 28 first. So we have 15 over the square root of 50. So what we're gonna do here is that we're gonna break this radical in this way. So we're gonna write 15 over, and then we're gonna have two radicals. One radical is gonna contain a perfect square, so we know that 25 is a perfect square, and 25 times 2 is gonna be 50. So we are breaking a radical into parts, and remember the purpose of doing this is because you're gonna get a perfect square. Otherwise you don't do anything of this. You just go directly and multiply by the square root of 50, both the numerator and the denominator. But in this case we can simplify the radical first. So we're gonna have 15 over, and 25 is 5 square, and then times the square root of 2. So we finish this first part because we are simplifying here. We haven't rationalized yet, so we are just simplifying. So you're gonna get 15 over 5 times the square root of 2. Why? Because we're gonna cancel this exponent and this radical. And we can continue simplifying before rationalizing. You know that 15 over 5 is gonna be 3 over the square root of 2. So now we're gonna rationalize, because if you give me this answer, you are not rationalizing, you are just simplifying the original expression, but you are not rationalizing. Some of you got up to this, but this is not the final answer. We still need to remove the radical in the denominator. To do that, we're gonna multiply both the numerator and the denominator by that radical. So now we're gonna get 3 times the square root of 2 over, and then we have square root of 2 times square root of 2, which is just the square root of 2 square. So now we're going to be able to cancel this exponent and this radical sign, and the final answer is going to be 3 times the square root of 2 over 2. So that's problem 28. Now problem 36. So let's go on problem 36. Uh, 36 is just the square root of 1 over 54. So first we're going to break this huge radical into radicals, one for the numerator, the other for the denominator. And then we're going to break the radical in the denominator in the same way that we did it before. So here you just the square root of 1 is just 1. Then 54 is 9 times 6. And especially this factoring is important because 9 is a perfect square. I can write 9 as 3 squared. And also I have my radical 6 here. So that's problem 36. So the next part is that we're gonna remove this exponent and this radical sign. So I'm going to end up the simplification. This is just, I'm just simplifying the original fraction. I haven't rationalized yet because I still have a radical in the denominator. But this is important. These steps are important to simplify our computations. So now we're going to rationalize. So we're going to multiply both the numerator and the denominator by the radical I want to eliminate, which is square root of 6. So then I'm going to get the square root of 6 in the numerator, and here I'm going to get 3 that multiplies the square root of 6, the square root of 6. So these two radicals are the same, so this is just 6 squared under the same radical. And then you can just remove this exponent and this radical, so you end up with the square root of 6 over 3 times. Then inside of this parentheses we're gonna write what was left from removing the exponent and the radical. So the final step is just doing this multiplication, so you're gonna get the square root of 6 over 18. So that's problem 36. Now the last problem, problem 50. Problem 50 is 45 over y cubed, the square root of this. So we're gonna break this into radicals first. 45 and the square root of y cubed. So the first thing that we're gonna do is I'm going to break this numerator into parts. So one part is gonna be a perfect square, so 9 times 5 is gonna give me 45, and 9 is a perfect square. The same thing in the denominator. I can break this y cubed as y squared times y. So y squared is a perfect square, and y is not a perfect square, and y squared times y is going to give me y cubed. So now we're going to simplify things. So 9 is 3 squared, 5 is just 5, y squared, we're going to leave y squared and y. Now we're going to cancel radicals and exponents. So I have this exponent, this radical, I have this exponent, this radical. So I'm getting 3 times the square root of 5 over, and here you, after removing the exponent and the radical, you end up with y times the square root of y. So this is the end of the simplification, but it's not the end of the problem because I still have this radical here. So now I'm going to do the rationalization part. So again, this is simplification. I'm going to write here, we are simplifying first and we are rationalizing now after. Rationalizing the denominator after. So how do we do that? We're going to multiply by the radical I want to eliminate. I don't want to eliminate radical 5, so I'm not going to multiply by radical 5. I want to eliminate radical y, so I need to multiply by radical y, both the numerator and the denominator. So now we're going to have 3 that multiplies, in this case, a radical, and we have 5 times y is going to be 5y. Those are radicals, so they remain inside of the radical sign. And finally, we have here y that multiplies the product of 2 radicals, so it's going to be y times y is going to be y squared. So now the last step is that we can cancel this exponent and this radical sign. So you're going to get 3 times the square root of 5y over y multiplying another y that results from this cancellation of the exponent and the radical. So the final answer is going to be 3 times the square root of 5y over y squared. So it's very important that you see here that you have 6 and 18 in the previous problem, and you might be tempted to say, oh, I can divide 6 by 3 and 18 by 3. But you cannot do that because this 6 is part of the radical. It's not alone. The same thing here. You can say, oh, I have y here and y squared here. Maybe I can cancel this exponent and remove one y. No, because this y is inside of a radical and this y squared is outside of a radical. So they are not of the same kind. So be careful about that. So now we're going to continue with the second class of problems that we're going to work on, which is rationalization. We're going to rationalize denominators containing 2 terms. So this is rationalizing denominators containing 2 terms. So now we have one more term, and this is on page 597. So what we're gonna do is, if you have like 7 over 5 plus the square root of 3, or 2 over the square root of 6 minus the square root of 2, we need ways for us to eliminate these radicals in the denominator. So I want to get rid of these radicals. So when you have 2 terms like this, either a sum or either a difference, we're going to use this special product we learned a lot of chapters ago. So when you have the product of 2 conjugates, you're going to get a squared minus b squared. So in this case, this is going to be very important because when you square a and b, you're going to be able to remove the radicals. So that's what you're going to do in this problem. You're going to multiply the denominator and the numerator by the conjugate of the denominator. Okay, that's what we're going to do now. So we're going to start with example 3 on page 597. So the problem is that we're going to rationalize the denominator. So the denominator, so the fraction is 7 over 5 plus the square root of 3. So that's the fraction. I want to rationalize this denominator. So I'm going to write my fraction. I'm going to use parentheses to enclose the denominator, and I'm going to multiply the numerator and the denominator by the conjugate of this denominator. Where is the conjugate? The conjugate is just 5 minus, because I have a plus sign here, then the conjugate is going to contain a minus sign. So 5 minus the square root of 3, and I'm going to do that also. I'm going to write that also on the numerator. So these two quantities should be always the same. Otherwise, you are changing the problem. So when you multiply by this kind of expressions, when you have this expression, the numerator and the denominator the same, that means that you are multiplying by 1. So you are not changing the problem. So then it's just doing operations. So the numerator is going to be just 7 times 5 minus square root of 3. And then the denominator is going to be, this is a, b, a, b, so a plus b times a minus b. So we need to write a square minus b square. So what is a? A is 5. We're going to square that, minus, and what is b? B is the square root of 3, and we're going to square that, 2. And then just finish our problem. On the first case, we're going to apply the distributive property here. So 7 times 5 is going to be 35, minus 7 times the radical 3 is just 7 times radical 3, over 5 times 5 is going to be 25. That's 5 squared. And here you just need to remove the exponent and the radical. So you end up with only negative 3 or minus 3. So the final answer is going to be just 35 minus 7 times radical 3 over 22. So that's example 3. Now we're going to work one more example, and then you're going to have now the opportunity to solve similar problems. And remember, this is very important. You're going to have problems like this in the final exam and also in the corresponding quiz and homework. So you better practice solving a lot of problems like this. So I have now example 4. Example 4 on page 598. So we're going to rationalize the denominator again. And now my fraction is the following. So I have 2 over square root of 6 minus square root of 2. So we're going to write here our fraction. We're going to enclose the denominator in parentheses. And we're going to multiply both the numerator and the denominator by the conjugate of the denominator. What is the conjugate? If I have here the difference, then the conjugate is going to be the sum. So it's going to be radical 6 plus radical 2. I'm going to write the same quantity on the top, radical 6 plus radical 2. And now I just need to do the operations that are indicated. So I'm going to have here 2 times the square root of 6 plus square root of 2 over, then this is a minus b, this is a plus b, so I need to get a square minus b squared. So a is square root of 6, I'm going to square that, minus b is the square root of 2, I'm going to square that. So I'm going to apply now the distributive property here. So if I do that, I'm going to get 2 times square root of 6 plus 2 times square root of 2. Or maybe I should leave it in this way. Sometimes it's better to leave this step at the last because sometimes you can cancel this or you can reduce this coefficient with the resulting part here. So, and that's what's going to happen now. You're going to see here. How do you simplify this expression? You cancel the square, you cancel the radical, so you get 6. Here you cancel the radical, you cancel the exponent, and you get minus 2. So I'm going to go back and write here 2 times the square root of 6 plus square root of 2, because I'm getting a denominator that can be simplified with the coefficient. So I have 2 over 4. So what do you do in this case? So you divide by 2 the numerator and you divide by 2 the denominator, right? That's the way that you simplify this coefficient. So 2 over 2 is going to be just 1, square root of 6 plus square root of 2, and 4 divided by 2 is going to be 2. So the final answer is just square root of 6 plus square root of 2 over 2. Okay, so applying the distributive property is going to complicate my things. So it's better to go back. So that's what I did here. So now you're going to solve problems like this. You're going to rationalize denominators containing 2 terms. So you have only 4 problems. No, only few problems. Try to simplify your answer. So we are working 8.4 exercise set on page 600. You're gonna solve only 4 problems. So 54 is 1 over 5 plus square root of 2. Then 62 is square root of 3 over square root of 3 plus 1. So it's important that you see where the radical sign ends, so to prevent mistakes. Then we have problem 70 is 6 over 4 minus the square root of x, and finally 74 is radical 5 plus radical 3 over radical 5 minus radical 3. So try to solve these problems, and then we're going to continue with the next section. So let's try to solve problem 62 first. So 62 is radical 3 over radical 3 plus 1. So the first thing, we enclose in parentheses our denominators and numerators when they contain more than one term. Then we're going to multiply by the conjugate of the denominator, and the conjugate of the denominator is going to be square root of 3 minus 1 in this case, because I have the sum, then I need the difference. And I'm going to use the difference 2 for the numerator. Then we're going to multiply just first, cross. So you get square root of 3, that multiplies square root of 3 minus 1 over, and then I have a plus b multiplying a minus b, so I need to get a squared minus b squared. So a is the square root of 3, I'm going to square it, and minus, and b is 1, I'm going to square it, it's just 1. So then I'm going to get square root of 3 times the square root of 3 minus 1 over, then we're going to cancel the exponent and the radical, so we end up with only 3 here, minus 1 squared is just 1. So we're going to get the square root of 3 multiplying the square root of 3 minus 1 over 2. Now in the last step, because we cannot simplify these two, remember we leave it until the end this operation because we wanted to see whether this coefficient could cancel or reduce with this denominator, but it cannot because this is a radical and this is not a radical. So I'm going to apply the distributive property. So I'm going to multiply square root of 3 times square root of 3 minus square root of 3 times 1. Remember, we write first the coefficient and then the radical, not on the other way. So first coefficients, then radicals, over 2. Then square root of 3 times square root of 3 is just square root of 9, and 9 is just 3 square, minus 1 times square root of 3 is just square root of 3 over 2. And finally, you just need to cancel this and this. So you're going to get 3 minus square root of 3 over 2. If you're using the chat box, you need to write parentheses for the numerator, 3 minus, and then you're going to use SQRT parentheses 3, that's the radical. I'm going to close this parenthesis. I'm going to divide by 2. This is if you are using the chat box to send me your answers. So now we have problem 70. Problem 70 is just 6 over 4 minus the square root of x. We're going to enclose in parentheses this. We're going to multiply by the conjugate. The conjugate is 4 plus square root of 6 over 4 plus square root of 6. Then we're going to apply the distributive property. We don't see that we're going to get anything that can be reduced with this coefficient. So 6 times 4 is going to be 24. And 6 times square root of 6, the square root of x, sorry, is going to be 6 times the square root of x. Over, then we're going to square the first one, 4 square, minus, we're going to square the second term. So the final answer is going to be 24 plus 6 square root of x over 16 minus, and when you eliminate the exponent and the radical, you end up with only x. So the extra problem that you're gonna solve now to complete your classwork is gonna be 72, which is 3 times square root of 2 over square root of 10 plus 2. So that's for your classwork. Now we're gonna start the last section, section 8.5. So we have section 8.5. This section is on page 602 and it's about radical equations. Radical equations. So that's the last section that we're going to cover from this chapter. So what is a radical equation? On page 603 you're going to find the definition. It says that a radical equation is an equation in which the variable occurs in a square root, or cube root, or any higher root, or any higher root. Okay, so we're gonna solve equations containing radical equations containing square roots. So radical equations with square roots. So on the same page, you're gonna have the steps to do it. So I'm just going to summarize. I'm going to abbreviate the steps. So you're gonna isolate one radical on one side of the equation. That's the first step. You isolate one radical. The second step, you square both sides of the equation. That's the second step. Then the third one, you're gonna solve the resulting equation. And finally, you're gonna test all solutions in the original equation. Why? Because anytime that you square an equation, you are introducing more roots than the original equation had. So that is going to be the last step. So let's solve some examples, and then you're going to have time to play with this by solving exercises from the corresponding exercise set. So we're going to solve sample 1 on page 604, and this is just the following radical equation. We're going to solve the square root of 3x plus 4 equals 8. So that's a radical equation because you have the variable inside of a radical sign. So the first step, we need to isolate one radical on one side of the equation. We already have one radical on one side of the equation, so the first step is complete. Now the second step, we're going to square. So we're going to have 3x plus 4. We're going to square the left hand side. It's going to be equal to 8 squared. So we are squaring both sides. So that's the second step. So, and we do this because now we're going to be able to remove the radical and the exponent. So you just write the radicand, remember? What is left? The radicand is left. And on the right hand side, I only have a squared is going to be 64. So now the third step is we're going to solve this equation. So we're going to solve the resulting equation for x. Okay, so how do you do that? You remove this 4 from both sides of the equation. So you end up with 3x equals 64 minus 4 is going to be 60. Then you divide by the coefficient of the variable. So you're going to get x equals 20. Now, we need to test the solution to be sure that it's the right answer. So we're going to do the testing. How do you do the testing? You evaluate the original equation for the value that you just obtained. So we're going to evaluate the original equation. So let's see. On the left hand side, I have 3 times 20 plus 4, and this should be equal to 8. Then I have On the left hand side, 3 times 20 is going to be 60 plus 4. This should be equal to 8. Finally, we have the square root of 64 should be equal to 8. So to be sure, we need to rewrite this as a perfect square. So we know that this is 8 square root equals 8. Then you remove the radical and the exponent, and you end up with 8 equals 8, which is true. So that means that the solution is just going to be x equals 20. So that's the solution for this problem. So that's the first problem. Let's work one more problem. So now I have example 2. On page 604, and it's going to be a solution to the following. So we have the square root of 3x plus 9 minus 2 times the square root of x equals to 0. So the first step, we need to isolate one radical. We have two radicals we can choose. In this case, there is no problem because once you isolate one radical, you are actually isolating the other radical too. So to do that, we're going to add 2 times square root of x to both sides of the equation. So if you do that, then you cancel this and you end up on the left hand side with the square root of 3x plus 9 equals 2 times the square root of x. Now, second step, we're going to square both sides. So we're going to write the square root of 3x plus 9 and we're going to square it. And we're going to do the same thing with the other side. So we have 2 times the square root of x square. Okay? So on the left hand side, it's just removing the exponent and the radical. So we have 3x plus 9. On the right hand side, we need to distribute first the exponent. So you're going to have 2 being squared, and you're going to have the square root of x being squared too. Okay? So you get 3x plus 9 equals 4 times what is left, times the radical, because the exponent and the radical sign vanish. So finally, you just need to work on this equation. So the third step is just solve for x. So in this case, we need to subtract 3x from both sides of the equation. So we get x on the right hand side equals to 9. So now the fourth step is we're going to test the solution. So we're going to test the solution. So in this case, we're going to evaluate the original equation, square root of 3x plus 9 minus 2 times the square root of x equal to 0, 4x equals 9. So remember, when you evaluate, you're going to replace every x with 9 in this case. So we have the square root of 3 times 9 plus 9 minus 2 times the square root of 9 and that should be equal to 0. So here we have 27 plus 9 minus 2 times the square root of 9. 9 can be written as a perfect square, 3 square. So here you're going to get the square root of 36 minus 2 times. And here you're going to remove the radical sign and the exponent. So you end up with the radical only, 3. So the radical is no longer a radical. Be careful. I say radical because here it was a radical. Later it's not a radical anymore because we remove the radical sign at the same time that we remove the exponent. So now 36 can be written as a perfect square. Is 6 square minus 2 times 3 is going to be 6. So here the same thing. We're going to remove the exponent. We'll remove the radical. So the radical 6 is left, but it's no longer a radical. Minus 6 equals 0. This is true. So that means that the solution x equals 9 is the right answer for this problem. Okay. We have another problem. So we have example 3. On page 605. So we're going to solve now the following radical equation. Radical x plus 5 equals 0. So again, the first step, we need to isolate the radicals. So we're going to subtract 5 from both sides. So we're going to end up with square root of x equals negative 5. Okay, so now we're going to square both sides of the equation. So we're going to square the left hand side, we're going to square the right hand side. So we're going to get, in this case, the exponent and the radical sign cancel to each other. So you get x. On the right hand side, just negative 5 squared is going to be positive 25. So now we need to test the solution. So we're going to do it now. So we have to evaluate. So we're going to do our test. We're going to evaluate the original equation. Square root of x plus 5 equals 0 for x equals 25. So that means that we're going to replace x with 25 here. So we're going to get the square root of 25 plus 5 equals 0. 25 is 5 squared plus 5 equals 0. Then we can cancel the exponent, the radical sign. So you end up with 5 plus 5 equals 0. So now we have 10 equals 0. So this is false. So that means that x equals 5 is not x equals 25 is not the solution. So we don't have more options than saying that x is just either no solution. There is no solution. There is not a solution. Or you can just write the empty set to indicate that there is no solution for this problem. So I think we have one more problem. So let's see. Let's go to the last example. The last example is example 4 on page 605. So we're gonna solve the following radical equation. The square root of 2x minus 1 plus 2 equals x. So first we're going to isolate one radical. So to do that, we're going to subtract 2 from both sides of this equation. So we get square root of 2x minus 1 equals to x minus 2. So now we have our radical isolated. So the next step is we're going to square both sides of the equation. So we're going to have the square root of 2x minus 1 being squared and also x minus 2 being squared. So the left hand side is going to be just this expression 2x minus 1. The right hand side we need to get the square of this binomial, which is going to be the square of the first one minus 2 times the first coefficient, the first member of this, the first term of this binomial times the second one plus the square of the second one. So 2x minus 1 is going to be x squared minus 4x plus 4. So now the third step, we're going to solve the resulting equation for x. So we're going to move everything to the right hand side to get the quadratic equation. So we're going to subtract 2x first. So we get negative 1 equals x squared minus 6x plus 4. Then we're going to add 1 to both sides of the equation now. So you get 0 on the left hand side. You get x squared minus 6x plus 5 on the right hand side. So now we're going to factor the quadratic equation to find a solution. So we're going to find two numbers that when you multiply them you get 5, and when you add them up you get negative 6. So those numbers are negative 5, negative 1, because you get positive 5 when you multiply them, and you get negative 6 when you add them. So you're going to break this as x squared minus 1x minus 5x plus 5. This is equal to 0. So we do factoring by grouping. So the greatest common factor of the first group is just x, that multiplies x minus 1. The greatest common factor of the second group is minus 5, that multiplies x minus 1. So at the end you get x minus 5 is one factor and x minus 1 is the other factor. Then the final solution is going to be obtained by solving these two equations. I have one equation to be x minus 5 equal to 0. The other equation is going to be x minus 1 equal to 0. So on the first case, you just add 5. So you get x equals 5. In the second case, you add 1. So you get x equals 1. So there are two solutions to test. So that's what we're going to do as our final step. So the final step is just testing the solutions. So we're going to start with the first one. We're going to evaluate the original equation, the square root of 2x minus 1 plus 2 equals x, for the first one, x equals 5. So meaning that we're going to replace every x with 5. So we have the square root of 2 times 5 minus 1 plus 2 is going to be equal to 5. So this is 10 minus 1 under the radical sign plus 2 equals 5, so it's 9 plus 2 equals 5. And remember, this is 3 squared plus 2 equals 5, so you remove the exponent and the radical, you end up with 3 plus 2 equals 5, which is true. So this is our first solution. Then we're going to evaluate the other solution. So we're going to evaluate the same original equation, the square root of 2x minus 1 plus 2 equals x, 4x equals 1. That's the other solution that we're going to test. So again, we're going to replace x with 1 in the question. So we have 2 times 1 minus 1 plus 2 equals 1. So we're going to have now 2 times 1 is 2 minus 1 is the square root of 1 plus 2 equals 1. So the square root of 1 is just 1 plus 2 equals 1. This is not true. This is false. So that means that the only solution for this problem is going to be just x equals 5. The one that we found here, that's correct. The other one is not correct. So it's going to write x equals 5. In the final exam, since you're going to have a multiple choice exam, if you don't do your testing, for sure you're going to have an answer that is going to contain both solutions. But if you choose that answer, you're going to be wrong. There are going to be another answer, maybe with this value, and the other answer with this value. So you need to be sure which ones are the solutions for the original equation. So now you're going to work you're going to solve some radical equations. You're going to submit your work either by using the chat box now or later by submitting your work through Canvas. So this is from 8.5 exercise set on page 607. So these are the problems that you're going to solve. You're going to start with problem 4, and that's the square root of x minus 9 equals 0. Then we have problem 8. Problem 8 is the square root of x plus 5 minus 8 equals 0. Then we have problem 12. Problem 12 is the square root of x plus 6 plus 1 equals 3. So be careful. There are numbers that are not part of the radical. So you cannot combine these two. You cannot combine these two. You cannot write x plus 7 here because this 6 is under the radical sign and this 1 is outside of the radical sign. Then you have problem 16 is the square root of 5x minus 4, and this is equal to the square root of 3x plus 6. Then let's see, we have problem 20. Problem 20 is the square root of x plus 8 equals 0. Then we have 36. 36 is the square root of 9x squared minus 2x plus 8. This is a trinomial under the radical sign equals 3x. And the last problem is going to be problem 38, and is x equals the square root of 3x plus 7 minus 3. So work on these problems, and with that we're going to finish this chapter.